Okay, good afternoon. And today's revision class for the building materials construction and planning. So we are going for the topic unit 2, tests on cement. So already we discussed the previous revision class. So what is the cement? What is the hydration of the cement? And what are the chemical composition of the cement? And what is the manufacturing process by using the dry process and wet process of the cement? And what are the different classifications of the cement, or we can say that the types of the cements we discussed the last class. So now the today's class will go for the test on cement. So why the test on cement will be required? Just normally for the any construction material we are going for the testing. The testing will be giving as the authentication report. The objective of the testing is that one. So we have to be know about that. So quality control and quality analysis. These are the two aspects we are going to be covering by using that the testing. So testing is more important. So we have to be analyze the material and we have to be give the report in the form of quality control and quality analysis. How the quality of the material, whether we can be able to use it in the construction or not, or otherwise we are going to be, if it is not going to be conforming to the Indian standards, so then we are going to be rejected. So that is the basic reason we are going for the testing of the construction material or testing of the building material. So that is the main objective. Main objective we are going for the testing for the construction materials. Now today's class we are going for the what are the various tests that we are going to be performed onto the cement, such that we know that the quality control of the cement. So these are there, the two classifications will be there. One is we can say that the physical test, or otherwise we can say that the test at the site. So the rapid test we are going to be doing, that is going to be called as a test at the site. We are going to be performing onto the cement, and we can able to so give the report related to the quality. Second one is laboratory tests. We are having the two classifications are there. So the contents we are going to be covering: classification of the tests at the site of construction, or the field test, we can say that other name. Another one is going to be called as laboratory test. So classification of the test may be one is so that the field test at the site itself, that is we are going to be called a rapid test. Second one is going to be called as we are going to be performing in the laboratory. It is going to be called a time consuming process. Then we are going to be giving that the authenticated report that we are going to be called, that is going to be giving as the quality control. So now why the test we are going to conduct? Already we discussed, but once again we'll go through that what is the standard definition. So quality tests on cement are carried out to check the strength and quality of the cement used in construction. So we are going for any construction material, we have to be satisfied that the requirements in the form of the characteristics is going to be called as one is strength, another one is going to be called as durability. Strength and durability, and in addition to that one, we have to be so conforming to that the quality of the material. If the quality of the material is going to be good, automatically it will be covering that the strength aspect as well as the durability aspect. So that is the main intention we are going for the testing. So it helps to identify the usage of the cement for different purposes based on its durability and performance. So one is strength, another one is going to be called as a durability, and how it is going to be performed, in where we had to be used, what are the different types of the cements we are going to be used, whether we'll go for the 33 or 43 or 53, where we can able to use that the 33, 43 and 53. So and there is the performances will be identified by using that the test alone. So then test on cement at the construction site. So what are the various tests that is going to be conducted? Is going to be called the first test is going to be called as the site, or we are going to be called as field test is going to be called the color test. Second one is the presence of lumps. Third one is adulteration test. Fourth one is temperature test. Fifth one is float test. Sixth one is strength test. Seventh one is the setting test, and last one is data packing. So these are the 1, 2, 3, 4, 5, 6, 7, 8 tests are we are going to be conducting at the site, or we can say that the field, to know that the quality of the cement. This is we are going to be called as rapid testing, or we are going to be called as physically we are going to be observing that the quality of the cement from the bag of cement, and we are going to be identify and such that we can be able to say that we can able to use it or not. So first one is going to be called as color test. So the color test is that always we have to see that the color of the cement should be uniform and should be gray color with a light greenish shade. This is the color. Always is the gray color. The green shade has to be there. So throughout the bag of the cement, it should be uniform. There is no color variations will be there. That we are going to be conducting. The test is going to be color by looking through the eyes. with the bag of the cement, we can able to identify it. If it is not conforming to this color, then we are going to be rejected. And the presence of lumps, there is no lumps will be there, no lumps inside the bag of the cement. Once you are going to be open the bag of the cement, we can are able to observe that there is no lumps will be there. If the lumps will be there, means it is going to be hardened, the cement is going to be hardened, and we cannot be able to use it for the construction. The cement should be free from any hard lumps. Such lumps are formed by the absorption of moisture. If the absorption of moisture only, it is going to be developing of the lump. Lump is going to be generated because of the moisture absorbed. Then automatically it is not the fine cement. It is not the powder form. It is the lumps will be there, and we cannot be able to use it into the construction. So any bag of the cement containing such lumps should be rejected. This is about the presence of lumps. First one is color, then the lumps should not be there. Then we can say that the cement adulteration test. What is the cement adulteration test? Is that it is going to be called a fine powder. Adulteration means the cement should feel smooth when touched or rubbed between the fingers. If it is felt rough, it indicates adulteration with the sand. Sand is mixed inside the cement, then it is going to be giving the feeling of rough. We are going to rub it between the fingers. You take that the pinch of the cement, handful of the cement or pinch of the cement, and you are going to rub it between the fingers. You have to be get that the smooth feeling. Then the quality of the cement is going to be good. That is going to be called as cement adulteration test. Then temperature test on cement. Always we are going to be keeping the hand in the inside the bag of a cement. We have to be see that cool feeling has to be get. If the hand is inserted in a bag of cement or heap of the cement, it should feel cool and not warm. We cannot get the warm feeling, but always we have to get that the cool feeling. So then, so the quality of the cement is good. Always we have to get the cool feeling. Then the float test. Another test we are going to be doing is the float test. Means here we are going to be, so the just you are taken the handful of the cement, just you are going to be thrown into the bucket of the water, and it should have to be float for some period of time, then it is going to be sink. Then the quality of the cement is good. So that is the float test. If a small quantity of the cement is thrown in a bucket of water, the particles should float for some time before it sinks. So this is going to be giving, if it is not going to be float for a float and it is not going to sink, then the quality of the cement is not good, is not up to the mark. We can able to, so the reject it. So then setting test. So the setting means setting properties of the cement. We are going to be for the random testing we are going to be doing. For that we are going to be preparing a paste with the water on a piece of glass plate, and is kept under water for 24 hours, and it should not, and it should set and not crack. It should have to be set with no cracks has to be, no cracks has to be visible on the paste. So if the cracks are visible on the paste, such that the cement is not a good quality. If it is so if not cracks are there, it is going to be set properly, then the cement is good quality. Then the strength of the cement, setting time, setting, and another last priority, last the physical test we are going to be doing is strength test. For that we are going to be preparing the molds with the water, and we are going to be immersed in water, for 7 days, and we are going to be tested, loaded with a weight of about 34 kg. The block should not show signs of failure. No cracking has to be developed. For the we are going to prepare the cement mortar mold. Previous case setting test, we are going to be preparing a paste, but here the mold is going to be prepared, and we are going to be tested after 7 days with the load of 34 kg approximately. It should not giving any failure, or should not show that any cracks onto that the mold. So that is the test we are going to be conducted. Or otherwise we are going to be preparing the briquette, or this is also irregular shape or the size of the mortar by 1:6. The briquette may be about 75 mm by 25 mm by 12 mm. They are immersed in water for a period of 3 days. After drying, if the cement is of sound quality, such briquettes will not be broken easily. So that is about 3 days we have been testing. It should not break easily. So with the given loading conditions is another one, another form of test we are going to be conducted to know that the strength property of the cement. One is block we are going to be preparing, another one is going to be briquette mold we are going to be preparing with irregular shape and size, and we are going to be tested after 3 days. So this is about the quality of the cement by using the strength and setting test. Last one is going to be called as data packing. This is a more important, almost all from the manufacturing to that how many days we can able to use the cement with a good quality. We are going to maintain the same quality and same color and same properties will be there. So beyond that period of time, you are going to be rejected because it is going to be exposed to the weathering actions. Automatically the cement will be having lumps inside the bag of the cement. That's why date of packing is going to be more important. How many days we can able to use it. Strength of the cement reduces with time. So it is important to check the manufacturing date of the cement, when it is going to be manufactured. Generally, the cement should be used before 90 days from the date of manufacturing. Within 90 days, we have to be use it into the construction such that the quality is going to be conforming to that the standards. If beyond 90 days, also sometimes it may be good, but sometimes it may be is moisture is going to be absorbed by the cement bags if you are not going to properly storage or properly storing the cement. So every chances will be there. The lumps is going to be so generated inside the bag of the cement, then we could not able to use it into the construction. So that's why the maximum time number of days we have to see that from manufacturing day is 90 days. Strictly we have to be follow. Within that period of time we have to be consume it. Then later onwards we can able to once again we can able to so procure the material, procure the cement, and then we can able to use it. So procurement will go for the so stage by stage, and we cannot procure the cement at a time in a large quantity. So there is a problem we are going to be able to face it. If you are going to be procuring the material cement bags at a large quantity or huge quantity, so then automatically so the loss is going to be occur, or it is not going to workable with the conditions, site conditions itself. So that is about that the data packing. So these are all we are going to be called as the so the field test, or we can say that the rapid test without doing any laboratory procedures, without doing any IS codal provisions. So we are going to be using with the eyes, and we using with your fingers or the hands. So that is we are going to be called as sensors. By using that the sensors, we are able to testing the quality of the cement, and we are going to be identifying the quality of the cement. So that is known as the field test or rapid test of the test on the cement. So then next is going to be called as second part is going to be called as laboratory tests performed on the cement. So one is fineness test, second one is consistency test, third one is setting time test, fourth one is strength test, soundness test, heat of hydration test, tensile strength test, and last one is going to be called a chemical composition test. In addition to that one, we are going to be one test also, we have one more test we are going to be conducting is going to be called specific gravity test. So these are the tests as per the Indian standard codal provisions or Indian standard code of practice. For each and every test we are having Indian standard code of procedures. Based on that the procedures, we have to be prepare the samples, and we have to be tested in the laboratory, and then we have to be prepare a report, and then we have to be submitted to the concerned authorities. So then that is going to be called as authenticated. Then only the quality is we are going to be maintaining for the cement, and the same quality is going to be used in the construction, so that the certificate will be necessary. So next we'll see that one by one test. Fineness test. First test is going to be called a very simple test is going to be called a fineness test. What is the objective of the fineness test? Fineness test is going to be called as measure of the size of the particles or the granular size. Granular size of the cement is going to be measured by using the fineness test. It is expressed in the term of specific surface area, centimeter square per gram. If it is small quantity, then we are going to be expressed specific surface area, centimeter square per gram. If it is a large quantity, then we are going to be called as meter square per kg. If we are going for in kg, then we are going to be use the unit is going to be called as meter square per kg. If it is a small, then we are going to be using a centimeter square per gram. It is an important factor for determining the rate of grain of the strength and uniformity and quality. So fineness test always it is going to be called as grain size or size of the particles. How fine is going to be contributing. Fineness is going to be contributing to that the particle size diameter. So that is the fineness test we are going to be conducting. The finer the cement, automatically the greater the surface area for the chemical reaction, and this the greater the rate of hydration also, and also the greater heat of the hydration. This results in the early development of the strength. So the early development of the strength always attributing to that the finer the cement. Most finer, more finer, automatically the strength will be more. Less finer, the strength is going to be decreasing. That is the main criteria we are going to be taken to the granted for the fineness test. But one should be careful that cement should not be grounded beyond a certain limit, as it may absorb moisture from the atmosphere and forms a slightly stiffened mass. This is called flash sweat. Still, if you go for very finer, fineness will be there up to certain extent only. But if you are going for very finer, then automatically it is going to be absorbing a moisture from the atmosphere, and then it is going to be the setting properties is going to be vary. That is going to be called a flash set. Flash means you can take the camera, just you have a click on that the flash. So is how it goes to the flash in a fraction of seconds. It will give the flash. The light will be comes out flash in the form of a flash in a fraction of seconds. So like that here also it will be set very fastly and it will be break. So cracks is going to be developed. That's why always flash setting properties is going to be avoided. If you are going for very fine, so this is the disadvantage we are able to get it the flash set of the cement. So then the sieve test is going to be IS 4031 part 1 is going to be giving as fineness is going to be measured by 90 micron sieve. Fineness is going to be measured by 90 microns. So very simple test we are going to be conducted. That is going to be giving as particle size. Here what we are going to measure is going to be called as particle size. Another test we are going to be conducted air permeability test. That in that by using that test we are going to be identifying or we are going to be evaluating that the specific surface area. Specific surface area is going to be measured by using the air permeability test, and particle size diameter is going to be measured by using that the sieve test. So this is a not modern test, it is a rapid test. In this test, cement is passed through 90 micron sieve and the residue left on the sieve should not be more than 10%. For ordinary Portland cement, so the IS 4031 is going to be giving the limit as that it should not more than 10%. If the more than 10% means it is having more lumps and the quality of the cement is not going to be good. So the fineness is not going to be getting, your fineness is not there in the bag of the cement. So it should not be more than 10%. Means whatever the residue after the 10 to 15 minutes we are going to be sieving through the 90 micron sieve, and residue is going to be left on the sieve has to be so the less than 10%. If it is more than 10%, so your fineness is not there in the cement. More lumps are there in the cement in the cement itself. So that is about the 90 micron sieve test. Another test already I told you that air permeability test, IS 4031 part 2. So this test is going to be used by the to know that the specific surface area. This test is better than sieve test and gives an idea of uniformity of the fineness. In this, compressed air is passed through cement and the pressure difference between incoming air and outgoing one is related to the specific surface area. And what are the limits that is going to be given? It should not be less than 2250 centimeters square per gram. Specific surface area for the ordinary Portland cement OPC should not be less than 2250 centimeters square per gram, and for rapid hardening cement RHC should not be less than 3250 centimeters square per gram. These are the standards by using the air permeability. Means permeability operators we are going to be doing, and we are going to be inserting through that one, through that the manometers we are going to be see that what is the specific surface area. So that is the air permeability test we are going to be conducting to know that the specific surface area of the cement. Here the objective of the test is to measure the specific surface area. Sieve test is that you measure that the particle size by using the 90 micron sieve. So that normally we are going to be doing with the sieve test alone. So air permeability test, unless otherwise special conditions only will go for the air permeability test. So then is another one is going to be called as next test is going to be called as consistency. IS 4031 part 4 consistency. In that we are going to be going for the normal consistency test, or we are going to be called a standard consistency test, and initial setting time and final setting time. So consistency means here you have to be get that amount of water should be added to the cement in such a way that we have to be get that paste in a proper manner. That is not the consistency. At what percentage the water we are going to add it such that we are able to get the paste in appropriate way. Means it is not going to be bleeding, it should not be dry. If the water will be more, it should be bleed, slushy. If the water will be less, the cement paste will be dry condition. Both the conditions are not suitable. We cannot go for dry, we cannot go for slush. So that in between we have to be get the cement paste, that is known as we are going to call it as optimum water content. How much water should be added such that your cement paste is going to be workable. That is known as the consistency. Consistency means it is going to be maintaining that the same limit, same condition. So that we are going to be called as consistency. So the term consistency is used to indicate the ability of the cement paste to deform with the change in water content. The water content changes, but consistent test is carried out as it is used as an indicator test for several tests for setting time, soundness test, it is going to be used. The results of the setting consistency we are going to be using in the setting time, initial setting time, final setting time, soundness, and also we are going to be using in the compressive strength test and the tensile strength test also. The same consistency is the amount of water or optimum dosage of the water, so that we are going to be calculated from standard consistency, that is going to be used for various tests. That's why it is going to be called as basis for several tests, indicator tests. The consistent test is used to determine the water required for testing, initial setting time and final setting time. For this, we are going to be carried out the standard consistency or normal consistency, initial setting time and final setting time. The operators we are going to be using as wicket operators. So the consistent test also meant by using the wicket operators. This test is connected to find the setting times of the cement using standard consistent test operators is known as the wicket operators. Here in the wicket operators, we are having that the mold. In the mold, we are going to be preparing that the cement and water paste. Cement, you are take the cement and then we are going to add the water. So where we have to be add the water, because we are going to finding out that the optimum water. That's why we are going to be starting from 24% of the water. We are going to be trial and error method. With the trial and error method, we are going to be starting from 24% and keep on, we are going to be increasing, and we have to be see that the penetration of the plunger from the bottom. Here it is going to be given the top 33 to 35 mm with the 10 mm diameter and 50 mm length of the plunger. Plunger is going to be penetrated into a cement paste 33 to 35 mm. That is known as the your standard consistency. Or otherwise 5 to 7 mm from bottom. We are going to be measuring the penetration 5 to 7 mm from the bottom, where we are going to be getting that point we are going to be called as optimum water content. Means you have got the penetration of, suppose I add the water with the, so the 25% with the weight of the cement. I am taking the 100 grams or 300 grams of the cement, or that 25% I am going to be calculated. That much of water I am going to be added. I prepare a paste and put into the mold. Then I am going to be operating the plunger to penetrate into the mold. I had to be see that what is the penetration. If I got the penetration, will be 3 to 5 mm. 3 to 5 mm from the bottom. 3 to 5. Suppose I got the 4 mm penetration. Then my standard consistency is 25%. My standard consistency is 25%, because with 25% of water added with the weight of the cement, I got my penetration is 3 to 5 mm. So then my penetration is, so my standard consistency is 25%, or 27%. I got that the penetration is 4 mm or 5 mm. Then my standard consistency or normal consistency is 27%. So that's the trial and error procedure we start, and where we are able to get that your penetration is going to be 3 to 5 mm from the bottom, or from the top, how much we have to get that 33 to 35 mm. That percentage of water we are going to be called as the standard consistency or normal consistency. The test has to be undergo 3 times. Each time the cement is mixed with water, varying from, already I told you that 24 to 27% of the weight of the cement. With the weight of the cement, we are going to be weighing, and then your water is going to be added. You're preparing the paste, put into the mold, and you have to be use the plunger. Here you are going to be using the accessory is the plunger. For initial setting time, we are going to be using the accessory in the wicket operators is needle. Then for final setting time, so the needle with the annular arrangement. Only one operators, wicket operators we are going to be using, but the accessories we are going to be changing. For the standard consistency or the normal consistency is we are going to be using as the plunger, and for initial setting time we are going to be using the needle, and next for final setting time, needle with the annular arrangement we are going to be using with the wicket operators. This is known as the consistency test on cement, or standard consistency or normal consistency, how we are going to be carried out in the laboratory. Main objective is that we have to know that optimum dosage of the water, optimum percentage of the water. This test should be conducted at a constant temperature of 25 degrees centigrade to 29 degrees centigrade, and at a constant humidity of 20%. So these are the operators. We can able to see that this is the wicket operators. This is the scale will be there. This is the needle we are going to be using for your initial setting time. This is the plunger we are going to be using for standard consistency. This is the thing we are going to be accessory we are going to be using. Annular arrangement with the needle with the annular arrangement will be there. We are going to be using for your final setting time. So this is we are going to be use the front view. Front view you can able to see that this is the gradations. The scale is there, and the weight will be there. Weight is going to be released, and the needle is going to be penetrated into the mold. And we have to see that So from the bottom, what is the penetration level? First, if you add the 24%, automatically it will be very hard. So then we are able to get that your reading will be, so the penetration will be very low, because it will be very hard. Your penetration also is going to be very slow, slowly is going to penetrated, and we are able to get the reading will be more than 7 mm, 5 to 7 mm. We told you 5 to 7 mm. So they from the bottom, but it may be 10 mm also is going to be coming because of that. Then we are going to be added for 25%. Then we have got 26%, then 27%. So 1% increment, or you can go for 2% increment also, based on that your penetration of first reading. For the same sample, not the different sample. For the same sample, we have to be take it out, and for that you are added first with the 20%, 24% of weight of the cement. How much water will be there? That much water added. You prepare a paste and put into the mold, and then we are going to be arrange that the plunger, and we are going to be, so they drop down the plunger into that the penetration. For the penetration, you have to see that the reading onto that the graduated scale. If you get that what is the reading, you can see that 9 mm or 10 mm or 12 mm. First we will get it, because of it is going to be less water. Then we are going to be 2% of increment we are going to be added automatically. Water is going to be increased for the same sample. Then your penetration may be gradually decreases from 10 to 8. Then we will get 7 or 6. Then we have to see that what percentage you got it. So the 5 to 7 mm penetration. So that is, in that way we are going to be conducting the test for standard consistency. Then the next one is going to be called a setting time. IS 4031 and part 5 is going to be giving you the procedure for to carry out the setting time, initial setting time and final setting time. Setting time is used to find extent of deterioration caused due to the storage of cement. One is initial setting time, another how we are going to be conducting the initial setting time. So in the initial setting time is, we are going to be conducting, so the initial setting time, we are going to be conducting here the water content, how much water we have to see that 85% of the water required to achieve the standard consistency, 0.85 p. So 0.85 terms of consistency. Suppose you got the consistency of 27%. So that is the 0.85 by into 25% of weight of the cement. That much of water should be added with the weight of the cement, and we have to be prepare the sample, and we use the needle here. Needle, we are going to be using the needle, and you have to see that the penetration. Once you are going to be here, when we are be here the initial setting time, here the parameter we have to be noted down is going to be called as time. From where we have to start the stopwatch, at the instant of we are going to be adding the water to the cement. At that time you start the stopwatch, you mix it thoroughly with that the 0.85 consistency, and you have to mix it properly thoroughly, and you put into the mold, and then you use the needle, and you have to penetration. So how much penetration you have to get it? Same thing, 5 to 7 mm. Up to 5 to 7 mm, what is the time you got it? That is known as the initial setting time. When you can able to get that, the time you are going to be called as at the, suppose you got the 6 mm penetration, then you start the stopwatch, stop the stopwatch, you noted down the time, that is going to be refers to that your initial setting time. Always for ordinary Portland cement, it should be more than 30 minutes. Actually, in the books they are going to be given 30 minutes, meaning that it should not less than 30 minutes. Always it should be more than 30 minutes. It may be 35 minutes, it may be 40 minutes, it may be 45 minutes, depending upon how the water cement ratio we are going to be using. So based on that one, we are going to be calculated, evaluated is going to be called as initial setting time. So initial setting time, we are going to be calculated by using that the 0.85 p. Here, this is the one of the important point you have to be remember that 0.85 p, and start the stopwatch at the time of mixing water and prepare the sample. At the time we have to start the stopwatch. You got the 5 to 7 mm penetration, then stop the stopwatch, noted down the time, that is going to be gives as your initial setting time. Then the final setting time. This is also the continuation with the initial setting time. Is the time taken from instant of adding water to the time at which cement becomes sufficiently stiff, hard, when it is going to be hard, to lose all its plasticity and resist definite pressure. Here also we are going to be using the 0.85p, and the needle with the annular collar. Already I told you that. Here the accessory we are going to be using needle with annular collar. Previous one is going to be called as we are going to use the needle. Lower down and the time at which collar fails to make the impression and needle does not make is reported as final sitting time. It is not going to be making any impression onto the mold. Then I means it is going to be very hard. So that is we are going to call as final set. Means already it sets. Your cement is going to be set. So then you noted down the time that is going to be called as final setting time. So final setting time is going to be always ordinary Portland cement is 10 hours, 600 minutes. Initial setting time will be, it should not be less than 30 minutes, more than 30 minutes, and your final setting time will be 10 hours, 600 minutes. This is for your check. So whether you did correct or not, and so based on that one, we can able to give the certification or the authentication. This is about that how we are going to be so performing the final setting time of the cement in the laboratory. So prepare the sample with the 85%, 0.85p of the water with the weightage of the cement. Then these are the timing. We can able to see that OPC, ordinary Portland cement, 30 minutes initial setting time, 600 minutes or 10 hours for the final setting time. Rapid hardening means it is early strength we are able to get it. Initial setting time is 5 minutes and your final setting time is 30 minutes. Low heat cement, initial setting time is 60 minutes and 600 minutes is the final setting time. These are the important values for the OPC, RHC, rapid hardening cement and low heat cement. So then the another test we are going to call as soundness test. The soundness test we are going to be connected to know that excess lime, excess magnesia present in the sample, present in the cement, it is going to be giving as expansive characteristics for the cement. So that's why we had to avoid it. So that's why we are going to be called as soundness cement. How to calculate? So the test we are going to conduct is going to be called as soundness test. Sometimes it is going to sulfur also. Cement may undergo undesirable expansion after getting set in, and this may lead to the cracking. Even why, what is going to happen? It is going to be expanded. The cracks is going to be developed. So that is unwanted expansion. It is going to be leading to the cracking and disintegration of the concrete and thus causing the brittle failure of the concrete. That's why we are going to be conducting that the soundness. So if this excess lime will be there, we are going to be conducting by using that the Leach-Atelier apparatus. If magnesia will be there, we are going to be conducting the test is going to be called the apparatus we are going to be using as autoclave. Autoclave, this is the important questions they are going to be asking for the magnesia. Excess magnesia will be present in the cement sample. We have to go for the autoclave test, and for lime we are going for the lime we are going for the Leach-Atelier apparatus.